Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over problems 29 to 31 of the Algebra 1 Common Core New York Regents Exam for August 2015. If you have any questions at any point in time during this presentation, feel free to ask your questions in the comments section below, and we will be glad to support you. Alright, let's start by taking a look at question number 29. It reads, how many real solutions does the equation x squared minus 2x plus 5 equals 0 have? Justify your answer. Now, to answer this question, we need to recall the role of the discriminant. Okay, so this is something you want to recall. First of all, you want to recall what the discriminant is. The discriminant is b squared minus 4ac. Okay, now where did this expression b squared minus 4ac come from? If you remember your quadratic formula, the quadratic formula is x equals negative b plus or minus the square root of what? B squared minus 4ac, and you have the entire expression divided by 2a. Okay, so all over 2a. Now, what is the discriminant? The radicand is a discriminant, okay? So that's where b squared minus 4ac came from. It's extracted from the quadratic formula. Now, what does this discriminant tell us? Well, it tells us some very important things. If b squared minus 4ac is less than 0, if it's negative, what does that mean? It means that you have no real roots. Okay, no real solutions. Okay, and then when b squared minus 4ac is equal to 0, guess what? You have one solution. That's known as a double root. Now, when b squared minus 4ac, if it's greater than 0, if it's positive, then you have two unique solutions. All right? The reason why we have no solutions for negative radicand is that when you take the square root of a negative number, you end up with what? An imaginary number. Okay? So when we're asking about how many real solutions this quadratic equation has, there's either going to be 1, 2, or none. Do we have to solve this equation in order to determine how many real solutions it has? The answer is no. All you need is to determine the discriminant and look at the sign of the discriminant. Is it positive? Is it 0 or negative? Okay, so let's go ahead and get started. When you're making use of the discriminant for a quadratic equation, you must first ensure that your quadratic is in standard form. Okay? And it is in standard form here. The degrees are in descending order, nicely arranged. So from this quadratic equation, I can clearly see that a is 1. That's the coefficient of my x squared. B is, let's write that properly. B is negative 2, the coefficient of x, and c is positive 5. Okay, so my discriminant is b squared minus 4ac. That's the formula. Okay, so let's go ahead and compute that. We have negative 2 squared minus 4 times 1 times 5. Okay, negative 2 times negative 2 is positive 4. Minus 4 times 1 times 5 is 20. 4 minus 20 is negative 16. Negative 16 is clearly less than 0. This is negative. Okay, so what does this mean? It means that we have no real solutions. All right, so we are asked to justify our answer, so we have to basically contextualize our results. Write a statement explaining the significance of this result in connection with the question asked. Okay, so let's go ahead and write it. Since the quadratic equation has a negative, remember all we care about is the sign, has a negative discriminant of negative 16, it has no real solutions. Okay, all the solutions are imaginary. Okay, it has no real solution, so that's basically the justification of that we're asked to write. Okay, let's take a look at number 30. It says the number of carbon atoms in a fossil is given by the function y equals 5100 times 0.95 raised to the x, where x represents the number of years since being discovered. Question: what is the percentage of change each year? And explain how you arrived at your answer. Alright, so to get us started, let's go ahead and write down the formula for this scenario. Okay, so formula. Now, when we're dealing with some fossils, what type of exponential situation are we dealing with? Is this exponential growth or exponential decay? Remember, we have two cases, okay? So we have y equals a times 1 plus r to the x, and we have y equals a times 1 minus r to the x. Okay? The one on top is growth, and the one on the bottom is decay. How do you know? Well, you look at the sign after the 1. Okay? For growth, you add the growth rate in decimal form to 1, and in decay, you subtract the growth rate in decimal form from 1. Okay? In a radioactive situation, as we talked about earlier, when an organism dies, what happens to the amount of radioactive carbon that's left in that organism over time? It diminishes, right? It starts to decay. So in this problem, we're taking a look at radioactive decay model. This is the formula that's applicable to this scenario. Okay, so this is an exponential decay situation. Exponential decay situation. If you were talking about things like population growth or investment growth, you can look at growth in that case. Okay. All right. So now that we've ID'd the formula that we're going to use, let's rewrite it again. We have y equals a times 1 minus r raised to the x power. Okay, this is the formula we're using for radioactive decay. The question asks us for what percent of change each year. So what I'm going to do is let's take this equation that's provided for us. So I'm going to write it underneath this equation right here. So we have y equals 5100 times 0.95. Well, let me just color code it so we can really see what's going on here. So 5100 times 0.95 raised to the x. Okay? So how can we figure out what the rate is in decimal form? The base of the exponent basically helps us to calculate what the rate is. From these two equations, we can clearly see that the initial amount is 5100, the power is x. The quantities in the parentheses can be equated to each other. So we have 1 minus r equals 0.95. So how can we get r by itself? We're going to solve this resulting equation that we got by equating the bases of this of these two exponents from the formula and from the problem. Okay, so let's solve that. Subtract 1 from both sides. You have negative r equals 0.95 minus 1. Subtract and keep the sign of the bigger one, negative 0.05. And then divide both sides by negative 1, which implies that r is 0.05 because minus over minus is plus. So what is the percent, what is the change each year, the rate of change in percent form? So this is decimal, r is equal to 0.05. How do you convert decimal to percent? You multiply by 100 or you move the decimal point to the right twice. So r is basically 5%. Okay? So move the decimal point back twice. Bam. So the question is, what is the percent of change each year? The percent of change each year is 5%. Okay, that answers the first part. Now don't forget the second part. We're asked to explain how you arrived at your answer. So all you have to do here is basically explain the process that you used here to arrive at your answer, okay? You're not trying to create anything fancy. You're just explaining what you did in word format. So explanation, how did we end up with the rate being 5%? What we did is we, by equating the base of the decay formula and the model and solving for r results in a value of 0.05. So what I'm saying here is we equated the formula. So this is a formula right here. And the model is basically what we were given in the problem, the decay model. So by equating the basis of the decay formula and the model, so let's be more specific. Okay, so if we equate them and solve for r, we're going to get 0.5, which is equal to, in percent form, which is equal to 55%. Okay, so 0.05 and 5% are the same thing. Okay, so that's basically the explanation of how we came up with our answer, a rate of change of 5%. All right, let's take a look at question number 31. It says a toy rocket is launched from the ground straight upward. The height of the rocket above the ground is in feet is given by the equation h of t equals negative 16t squared plus 64t, where t is the time in seconds. Determine the domain for this function in the given context. Explain your reasoning. Okay, so what is the domain? Well, the domain is the list of acceptable input values into a function. Okay, so we have the height function h of t equals negative 16t squared plus 64t. The domain is the constraint on the independent variable, namely the time. Okay, so when is the time valid in this for this model right here? So let's just write some notation down. So domain is basically the constraint on t in this case. Constraint on the time t. Okay, t is valid for this model from when to when? For this model, from launch, that's from the point in time when the rocket was launched till it hits the ground. Okay, so that time period is basically the domain that we're talking about. So let me illustrate it for you graphically. So let's say we have a graphical situation right here. Now, if you graph this function, this is a downward opening parabolic curve. When you launch the rocket, if you start your clock, of course, is at 0, and then you launch your rocket, what's going to happen is going to go up, and then when it runs out of propulsion, whatever is propelling it, it hits its maximum, slows down because of gravity, hits its maximum height, and it heads back down. Okay, so the time from this is uh, this is when it hits the ground, and this is the launch. So the time from the launch to when it hits the ground, this constraint on t basically represents your domain. Okay, so domain, remember, domain is the horizontal span of the graph along the horizontal axis. The range, on the other hand, is the vertical span of the graph. That has to do with how high does the ball go. Okay, so in order to see to calculate the time when it's launched up to the time when it hits the ground, we're going to solve this equation. We're going to solve for when the height is equal to 0, because it's equal to 0 at 2 points in time for the whole experiment, and that is the start and when it hits the ground. Okay, so let's go ahead and do that. So we'll set h of t equal to 0, so we have negative 16t squared plus 64t equal to 0. Okay, all right, let's go ahead and solve this. I like to divide everything by -1 first, because I like my leading coefficient to have a positive sign. You can divide by -1 or multiply, it's the same thing. Okay, so you have 16t squared minus 64t equals 0. Now, I like to reduce this equation by dividing by the LCD. What is the biggest number that goes into 16 and 64? If you multiply 16 by 4, you get 64. So the LCD of these two is actually 16, since 16 is a factor of 64. Okay, so what am I going to do next? I'm going to divide again by 16. Every single term by 16. You want to simplify your quadratic as much as possible, so when you start solving, it's less complicated. Okay, so we have t squared minus 4t equals 0. Now we can solve by factoring. Okay, t squared minus 4t, we can factor out t, and we're left with t minus 4 set equal to 0. Next, we're going to use the zero product property to set both components to 0. So we have t equals 0 and t minus 4 equals 0. This is already solved for, so for the second one, you just add 4 to both sides, and then you get t equals 4. Okay, so t equals 0 is the start, t equals 4 is when it hits the ground. Alright, so what does that mean? It means that our domain is, let's see, what notation are we asked to use? Well, it didn't specify. So 0 less than or equal to t, and t less than or equal to 4. You can write it like this, or you can write it in interval notation from 0 to 4. Alright? Okay, so we can't stop here. We're asked to explain our reasoning, so let's just contextualize the result. Let's explain what this is and why it is the domain for this scenario. Okay, so all you just simply say is that the domain is 0 less than or equal to t less than or equal to 4 because the rocket was launched at t equals 0 and hit the ground at t equals 4. Okay? This is a time interval. This is the time interval that the quadratic model is valid for. Quadratic model is valid for. Okay? Anything other than this, it doesn't make sense. If you go beyond 4, what's happening is that it's going into the ground, and that doesn't make any sense. Okay? So from takeoff to touchdown, that's the time interval that's acceptable inputs of this function are valid. Anything else is unacceptable. Okay? So just writing this statement is sufficient to convey your reasoning to your grader. Thanks so much for taking the time to watch this presentation. We really appreciate it. If you found the contents of this tutorial beneficial to you, please give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions about any of the contents we covered in this clip, please ask your question in the comment section below, and we'll be glad to support you. More clips can be found on mathbuster.com, and don't forget to subscribe. Thanks again for watching, and have a wonderful day.